Hello everyone, welcome to the webinar regarding the CheckFox and Sigfox coverage measurement. We'll wait like for 2 minutes for the latecomers. In the meantime, if you could provide me a feedback, how is the video, how is the voice, whether you hear me well and whether you can see me well. Thanks, Philip. And again, we have participants here today from America, so good morning to Americas. And we have here people from Asia, so good evening. This time we are doing just one webinar, one event. We plan to do 2 events in the autumn time period, so you wouldn't have to wake up at 7 o'clock in the morning or to go bed too late for the webinar. Today we are going to talk about CheckFox. CheckFox has been a product in development basically since 3 or 4 years nowadays, going through many prototypes. And it was an internal project at Simple Cell Networks where we needed a device for several reasons. We needed to measure the coverage. We needed to provide a tool to the customers. I'll talk about it later on. And in the latest iteration, it's in the version 2.0, and it's a product that consists basically of 2 parts. One is the hardware part, one is also the dashboard. The CheckFox dashboard will be demonstrating in the second part of the webinar. What is important to understand that CheckFox for us is kind of a product that serves basically to support the Sigfox community and to support Sigfox operators. We are not making any money on it, so basically we are selling it. We are losing money on it, so it's not a very profitable product so far, because mainly it's used by Sigfox operators and by integrators. In the future, we hope it will be used for the field installations, where the numbers would go into thousands. Currently, we are selling just hundreds of the products, so we are not in the thousands where we would need to be in order to break even. This webinar is intended, it's an intermediate level, so not very highly technical, but also not a newcomer. You should know what Sigfox is and what it is about. It will be roughly 30 minutes presentations, and we'll have, again, a space for Q&A. And just shortly, for those who doesn't know me, I am co-owner of Sigfox operators in Central and Eastern Europe, and also have been with Sigfox since 5 years, handling hundreds of projects, talking with thousands of customers. So I have a little bit of background behind me. And since a year, I do concentrate on the hardware, on the devices, and on the platforms in order to support Sigfox. There are main 3 usage scenarios for CheckFox, and one should clearly distinguish between them. One is that Sigfox operators need to compare real coverage with a predicted model. That's, for instance, how SimpleHW is using it, or also Sigfox France is using it extensively to really see whether the computed model, the computed coverage given in the coverage map really maps to the real life situation. That's one usage. The other one is also for Sigfox integrators to measure coverage before starting any POC. If you want to do a POC with an insurance company, you want to measure their building, you want to measure how it behaves inside the building, you want to measure how it behaves, how the manholes covers are covered. So definitely system integrators should have the CheckFox in order to be able to prepare a POC and to see whether it works properly, the coverage. And the third one that we have big hopes in, and we think it's important, is for the field workers to measure the coverage before starting any field device installation. Basically, if you do a water meter installation, so you want to be sure that there's coverage on the spot, that there's coverage in the hole before you do an installation, because after you do installation, it costs you time, money, etc. So it's a device that basically gives you immediate feedback about the spot coverage. And that was also one of the reasons for which we don't have a combination of a Bluetooth device with a mobile phone. Definitely, it would be easier for setup. It would be easier for us to do the programming, to have like a two-piece installation. But we think that for the field workers, combining any device with a mobile phone, it's a complication. So we opted for the solution where we are combining all the functionality into one racked device that can survive the field installation and rough handling by the field workers doing the installation of the devices. I will start with something that it's not very entertaining, but I think it's quite important, and Sigfox should be definitely doing more in this field and should be pushing the Sigfox operators, integrators more into the methodology how to do the proper coverage measurement. This is a methodology that we are suggesting you to use. You can of course modify it, but those are the experience that we have from the field and from the hundreds of projects that we have been running. And definitely the first question should be, why do you do the measurement? Always start with the why. And so it's not that just, you shouldn't just start a measurement, but you should know why you do the measurement, because then you have different steps to take in for each of the reasons. So the first reason would be, of course, whether the predicted coverage match the actual coverage. Then the question is whether the reference device works at will work at the installation spot. Pretty important is also the attenuation. So basically the difference, the loss that you get between a reference measurement point, which is always, reference measurement is always done outside of the building, and the final destination. So for instance, you can come to the conclusion that the coverage is okay, but because there's a steel building with metal plated window, there's a big difference in attenuation between outside and inside. And you for instance, you need to do micro coverage with micro base stations in the office building. Then of course there can be a question, how is the reliability of the reception and of the performance over time, whether there are not any fluctuation between day and night, whether there are no fluctuation between weekends and working days. Sometimes we have seen, for instance, the interference, the noise, the background noise in the spectrum is of course different between night and day, and different between weekend and working days. There can be some kind of interference showing only in specific periods of time. So if the installation is very sensitive, we recommend doing of course over the time reception checking. And also you can use it as a reference point, telling you whether your hardware device works as well as the reference design. Traditionally, Sigfox operators have been using the black box, so-called black box for it, or the RNA tester, or even Sensit. Sensit behaves pretty properly from the radio perspective. So Sensit is sometimes used as a reference design, but CheckFox can be used as a reference design as well, a reference device. So when we are talking about the measurement protocol, we always recommend to have a written protocol. It can be electronic, but it should be clearly given. The reasons for the measurement, the name, who was doing the measurement, because very often it's very complicated to hunt basically who was doing the measurement, and if you need to get any more information from the person, so it's always good to have his name, ID of the reference design, so you can check the results in the backend, date, time, and place. Ideally, where the photos are stored, we definitely recommend taking photos for any kind of measurements, because it can give you a lot of clues. It can give you a clue that the place was totally wrong, that it was measured somewhere else than you thought that it would be measured, or the final place of installation was completely somewhere. You were told that it would be in the -1st basement, and then you discover that it was in the garage without any windows, without any access to the ground level. So it's pretty important to take photos. And also any remarks if there was any kind of extreme weather, snow-covered streets, or I don't know. It's always good to have notes about the weather conditions or the auxiliary conditions. Before the measurement, we always ask to go through a checklist. Basically, the same way as when you start an airplane, so you go through a checklist. So we definitely recommend to have a checklist for the measurement. So ensuring that you are not using a dev kit. We have seen many measurements doing a dev kits that sometimes can work, but it doesn't need to work that well. Check the antenna. We have seen many cases where the antenna was, where the measurement was done and the antenna was completely loose. So check the antenna whether it's not loose and whether it's a proper antenna. Definitely check the device voltage. Nowadays, CheckFox provides you warning if the voltage is too low. But if you would be using other devices, check for the voltage, because some of the devices can emit even if the voltage is low, but the emission would be at lower power output. So it's hard to then distinguish whether the reason for no coverage was the low voltage of the device or the actual lack of the coverage. We also recommend taking a photo of the device before any kind of measurements. We have lived through many situations when people were telling us, "Oh, we are using the reference device, this and this," and then we discovered that they were using dev kits, or they were not using the device that they were telling us. So please ensure that you have a photo of the device, and of course decide what you want to measure and how you will evaluate the results. So the same way as we recommend in the sales process to be prepared and to do the definition and to really commit 80% of the time in preparation and 20% of time in execution, the same we recommend doing in any kind of measurement situation. Really think about the measurement, and only after the preparation, only after the definition, do the real measurement. This is the reference measurement is a specific measurement, which basically should match the coverage map. The coverage map is calculated at 1.3 meters above the ground in open sky. The device needs to be at least 1 meter from any wall. We recommend putting it either on a tripod or holding it in the hand, but definitely not moving with the device. We recommend taking photo of the device in the measurement environment, again, to be sure that the checklist was followed properly. If you are using CheckFox, ensure that you have a GPS fix, that you have precise location, and basically then we also recommend doing, if you really want to be sure, we recommend doing the measurement several times. Sigfox has something that's called black spots and white spots. So there are places where there could be slightly better and slightly worse coverage. So we recommend slightly moving even the reference measurement by lambda quarter, which is about 8 to 9 centimeters, and doing at least 3 reference measurements. And then we recommend to check the dashboard that the predicted coverage matches roughly the measured value. If it's completely off, we recommend contacting the Sigfox operator in order to understand what's happening, whether there's some kind of base station down situation, or whether there's something wrong with the device, or whether there's something wrong with the interference on the spot. But there shouldn't be a major mismatch between the predicted coverage and the coverage that we are measuring with the CheckFox. And then the final step is assess the results. So compare the results with the measured coverage from the predicted coverage. You can get the predicted coverage for the spot through the Sigfox API. So Sigfox API can tell you precisely using a GPS location. Precisely, it would be roughly the predicted coverage within 200 meters environment. So it's not precise to 1 meter, but it should be telling you pretty well if you give it a GPS location, so it returns to you how many base stations this spot should be covered with. Please also bear in mind that the coverage can be influenced, like if you are calculating it behind a big rock or in kind of very hilly situation. So the results can be, of course, different from the coverage model, especially due to the averaging. So the coverage model can be calculating, and it happens quite often. The model is averaging the area. So if you are measuring it under a hill, so the hill is covered very well, and if you are like 20 or 30 meters under the top of the hill, the coverage model predicts that there's still good coverage, or the API predicts that there's still good coverage, and it doesn't need to be because you are in the shadow of the mountain. So always think about, even when you are evaluating the results, think about that we are still working with averages, and assess the topography of the place. When you do the final installation place measurement, we recommend basically to do 3 things. Not to start with the final place of installation, but we recommend always to do the reference measurement. So you want to be sure that the predicted coverage matches the real coverage. And then we also recommend doing the in-between steps. So if I am, for instance, doing a manhole cover measurement, so we recommend doing the measurement 1.6 meter above the ground. Then we recommend doing it directly at the ground level, and only in the third step to do the measurement under the ground with the manhole covered. That you have more reference point, and you can better understand what are the reasons for good or bad coverage. Again, definitely take the photo of the final place, and also we recommend doing a photo of the environment. We have seen situation where we were baffled why there was no coverage, and we just discovered, for instance, that the square was totally encircled by metallic clad buildings, and there was no way how a signal. There was no even a proper GSM signal. So it's always good not only to take photo of the device or the installation space as well, but to take photos of the environment, so the people doing the evaluation can assess it better. And then do the evaluation, assess the results, and compare the results in the dashboard. We are supporting, and I'll talk about it later on, we are supporting also over time period measurements. So you can measure it like each 10 minutes or each 60 minutes. And you can assess, because we are able to do several hundreds of measurements on one battery charge. So you can measure it you can keep the device on the place for the whole week, and then you can assess whether the reliability of the signal is stable within the time. And then we of course also recommend doing the comparison with the final hardware. So once you measured the coverage with the reference design, with the reference device, you can compare it with the final product, and you can see whether there's a big difference between the reference device and the final product. So resume for the measurement methodology. Just a really easy question: how is the coverage match? Whether the reference device works in the final installation? How is the attenuation between the outside and the inside? How is the long-term reliability of the messages? And how does my hardware perform in comparison with the reference design? We can come if you would have questions. I recommend keeping them to the end of the webinar. If you would have any questions regarding the methodology, also the methodology is online. There's a URL in the presentation, so you can download the methodology and you can use it, or the checklist, and you can use it on your own. If you would have any questions, let's keep it for the Q&A. So what's inside the CheckFox? Basically, we think that it's currently the most complicated Sigfox device in the market, and it's also assembly language program. So in order to be reliable and field deployable, we opted to program it in assembly language, not to use any compilers. And it's a device. It contains 45,000 lines of code, so it's not. It's a like long-term project. It's a lab project, and inside it contains a GPS module for precise location. For GPS, one needs to comprehend. One needs to understand that, and we are a little bit spoiled because we think that GPS works the same way as we have the Android phone. So now I'm under the roof here, and one would think that GPS would see me. It's not so. GPS works only under the open sky. So when you are using Google Maps on your mobile phone and you get a precise location, it's not because of the GPS, but it's because of the Wi-Fi or BTS sniffing and of the gyroscope that the Android uses or iPhone uses. So one needs to understand that this GPS and any GPS really works only under the open sky, and it doesn't work behind metallic windows, and it doesn't work with in the truck under the metallic cover, and it doesn't work if it's covered by any goods. So really, GPS is something else than we have in our mobile phones. The other thing is that the GPS fix takes some time. We are working on shortening the period of time between the GPS fixes, but when you first switch on the device, it normally takes around 40 seconds to get a GPS fix under the open sky. So you have to be a little bit patient. But once it gets first fixed location and the device is only in standby, so the next fixed location is quite shorter, and we have shortened it even in the version 2 of the CheckFox. Then we are a little bit heretic because we are not using Sigfox for data transmission. We are using GSM for data transmission. Basically, the reasons for it is that we need to transmit far more data from the device than Sigfox would allow us. So besides the precise GPS positions, we are transferring acceleration, we are transferring temperature, voltage, we are transferring speed of the device. So there are currently also the Wi-Fi, the Wi-Fi sniffs. So the data package that we are transferring from the device, it's not small, and therefore we need to use GSM for data transfer. Then there's a memory inside of the device for the data logging. We use data logging mainly in two cases. One is the case where we do where there's no GSM signal, because if you are doing the measurement of Sigfox in some basements, Sigfox still can be there and GSM is not there. So we are logging all the results, and once the GSM is available, you can upload or sync the results to the backend. That's one reason. The other one is also when we do the periodic measurements. For instance, when you put it in the car and you do measuring while driving, we are not sending the data after each measurement, but only after the whole period of measurements. We send the whole data log, so we keep the data in order to also to consume energy. So we are not sending opening GSM connection each time. Then in the version 2.0 we have added a Wi-Fi module for collecting MAC addresses. And it's basically usable for two things. One is when you have no GPS, so you are able to position to know the position of the measuring of the measurement using the Wi-Fi MAC addresses. And the other one reason for which we have Wi-Fi is that then you are able to compare the positioning results from pure Sigfox Atlas, from Sigfox Atlas Wi-Fi, or from GPS. So you know the precision between each of the measurement technologies or localization technologies, and also because you have all the MAC addresses that the devices collect, you can assess whether it makes sense to use one MAC addresses, two MAC addresses, three MAC addresses, whether RSSI it's something that's usable or not. So you can do a lot of field testing and field measurement because you have all the data in one data package. And not least, we have also the OTA, over-the-air upgrade of the firmware. We are still working on the improvement of the firmware. So through GSM, you are able to do over-the-air update. So as I told you, we have released like a month ago. We have released the latest version 2.0. We have improved the internal construction, so the PCB is better fixed and it can survive any kind of impact. We have better antenna fixing, so the antenna cannot be screwed so much that it would loosen the antenna. So we have that one. We have a water resilient USB-C connector. So it's water. I wouldn't recommend directly putting it into water, but it definitely can survive rain or humidity. We have added Wi-Fi module, and we are also shipping. We have changed a little bit the model because we have seen some people have hard time getting SIM cards into the device. Even we have video instructions on the website how to get a SIM card. You just unscrew the 6 screws and you put in the SIM card. But there were many customers who were a little bit reluctant to open the device. So we are shipping now the device with the prepaid SIM card. But you can switch to your own SIM card, or you can use the global prepaid SIM card, and you can reload it online with the money. The data plan, you really don't need that much data. We are transferring only the minimum needed. So you are not going to spend huge amount of money on the data plans. What we have omitted this time is that we have omitted the Sigfox connectivity. There were basically two main reasons. One was that we didn't know in advance to which country the device is going to be shipped. So it's a little bit complicated in the Sigfox ecosystem than to set up a global connectivity. That was one reason. The other one is that SOs ask us to get it without connectivity. Because they want to use our customers, because most of the customers, they have already connectivity, so they ask us whether they can use their connectivity. So, and if you don't have connectivity, you can always buy it at Sigfox.com. So we opted not to give away the free connectivity because we don't have the it's not practical, I would say, and you can purchase it online anytime. Let's now go to the logic a little bit behind the measurements, and also that's basically why I started with the methodology instead of the device and the dashboard itself, because we have seen many measurements in the past where we have the data, but we didn't have any clue what the data meant. We didn't have any clue where the people measure it, by which device they measure it, what they wanted to achieve. So we are basically guiding in the user interface. We are guiding the customers to tell us precisely where they are measuring and how they are measuring. So if I start the device, I got now from the standby mode, and let's hope that it will be. I didn't try it, but you should be able to see the interface. So in the first step, you don't start with measurement, but you start by telling the device where are you measuring, whether it's reference measurement. I'm sorry, this menu. You start whether it's outdoor above 1 meter, whether it's the reference measurement at 1 meter, whether it's at ground level, indoor or deep indoor. Basically, we recommend indoor would be like a normal room with windows. Deep indoor would be rooms without any windows. Attenuation for the classical indoor should be around 20 dB, and deep indoor should be 30 dB or even more, especially if you have office buildings with metallic windows. So the attenuation there can be between 30 and 40 dB behind the metallic windows. And those are just tech. They don't influence the measurements, the real measurements anyhow. Those are just tech that we are transferring to the dashboard, and which tell you what kind of measurement, how you should interpret the data. Then if I press, I'm here indoor, so I press indoor, and now I tell the device what I'm measuring, whether I do a survey or whether I do the final destination. Again, it's just a tag, and also telling it how many times should I be doing the measurement. Sometimes I want to do it more times in order to be statistically more proof. Now I'm transferring the signal. I'm not sure I will get the results right now here because we are transferring this device ID, but we hope that it will be transferred in 10 minutes in order to show you the results directly on this device. In the screen between this one, there was a GPS location. If you have no GPS, so you are able always to do. You are always able to press the back key to skip the GPS fix. Okay. Waiting for newest messages. I think that we are transferring the device now. Okay, so it didn't work, but it normally if let's try it. Let's try it once more in 10 minutes. Again, it's the issue is with the token here. Then you can also do periodic measurements. Basically, there are two scenarios: either that you want to measure while you are driving and traveling, so it gets all the GPS locations of the different points, and also the one, and you can decide whether you want to measure it each 1 minute, 10 minutes, or 60-minute intervals. It also logs the speed of the device, so you can then do statistical analysis, what kind of speed has influence over the coverage. You know that the speed. There are many myths about the influence of speed on Sigfox. Basically, the main influence is fading, which is only between 40 and 60 kilometers per hour, and only in the base station is in the vector of movement of the device. So if you have a highway and the car is going to the base station, and there's only one base station, so there can be fading or attenuation of the signal as the car is approaching the base station. Therefore, for instance, in the Czech Republic, we are building, or in Switzerland, we are building the network in such a way that always you have multiple base stations covering the highway. We are also doing highway coverage at minus 30 dB margin. And what we are also doing is that we are trying to put the base station not directly on the highway itself, but put it perpendicular to the highway, so the cars are moving perpendicular, and the fading effect is not that much proclaimed. But once the car reaches over 60 kilometers per hour, again the fading is not there, and the Sigfox works pretty well. But you should try it yourself. You would see with your own experience. And there's also a downlink test. There's currently a slight debate because theoretically it's a budget link, so it means the sensitivity of the devices in the uplink and downlink direction should be the same. There's currently a slight debate whether it's always true. In the field test, we think that the downlink is a little bit weaker, but you can try it on your own. But the difference is definitely not huge, and Sigfox is pushing very hard the device manufacturers the downlink to be as sensitive as the uplink. So basically, if you do Sigfox verified, they are still pushing. They are pushing. Not any device is not allowed to have better uplink than a downlink. Then we have the service menu, and you have many options in the service menu. I will mention just 4 of them. One is the data log update in case GSM is not present. So this can be useful. Then we recommend doing always the firmware update. Also in the about section, you have all the information about the email, about the ID of the device, radio zone. So all the information is there. And also, if you have a version supporting both RC2 and RC4, there's a way how to switch between RC2 and RC4 in the services in the service menu. So now we have measured. Let me. Maybe I'll mention one more thing. The device uses a standby, so it automatically gets, if you are not using it, it automatically gets into a standby regime. Default setting is 5 minutes, so it saves energy. And if you are not using the device switches off automatically after 6 hours. So even if the field worker forgets to switch it off, it switches off itself automatically. Of course, it doesn't switch off automatically if it's doing any measurement. And I will just. So we have the CheckFox dashboard. It's as the address which is given here, checkfox.simplehw.eu. And basically there are 3 ways how to get to the collected data. The first, you can see it on the display, of course, of the device immediately. But if you want to work on it, if you want to process with the data, so there are 3 ways. One is definitely the API. The API is described in the documentation at ask.simplehw.eu. Then all the dashboards, the dashboard itself contains exports to CSV and XLS, and also the dashboard provides for dashboard visualization, so you can see the data immediately in the dashboard. And I'll have a small presentation in a few minutes. And basically, there are six functions of the dashboard. One is the device setup. I will be not tackling the device setup this time because either you have ordered the device or you want to set it up. but there's a complete 3-page document describing in detail each step of the device setup. It's not the easiest one, but it shouldn't take you more than 10 minutes to set up a device. It's matter, and if you have more devices, so it's basically just first time setup, setting up callbacks and setting up APIs in the Sigfox backend in order for the dashboard to be able to read the data. But that's the device setup. Then you have the user management and rights setup. You are able to give different level of rights to different users and to different groups. So it's ready really for the field measurement when you have tens or hundreds of devices in the field, and for each of the worker you want to have a specific access rights. You are able to list the data. You are able to do the data export. You are able to do data visualization, and you are able to do a little bit of the data comparison, and I'll show you the data comparison in a short while. So now I'll try to switch to the desktop sharing. Just give me 1 minute. Okay, you should now be able to see my. Are you able to see my desktop? Or my? Yes. Okay. Thank you for the feedback. So. Okay, here we are. So basically, this is the dashboard. This is the dashboard of CheckFox. You can see the measurements. You can see the measurements for different devices. So you can choose a device that you want to see, or CheckFox you want to see. Here you are managing the users. You are able to add new users, delete users, give them different rights. You are always you can give the rights either by device or by users, and here you are managing the devices as well. So you can see the latest location of each of the device and what's happening with them. There's a different view on the device rights on the devices. Then company settings, that's the place where you are setting up the callbacks and the API access credentials. You will not see firmware manager. Firmware manager is just for us as admin, and you have a link to the help. Currently, the login supports only Google accounts, so please be patient. We hope to have more ability to access. But for us, easiest if we are using currently any kind of, it can be Gmail or it can be Google Apps account. We are not reading definitely your emails or data, but we are using it for user management. So here is the list of measurements, and what we are always listing is the device. We are listing here the mode. Basically, int means it's an indoor mode. The tag is indoor. It was the type of measurement was survey and just one message. We can see directly the number of stations that received the signal and the repetition. We can see best signal to noise ratio, best RSSI. We can see basically atlas location, GPS location. We are also doing reverse geocoding, so we are able to see the precise address of the measurement and date and type of measurement. Let's see. This is, for instance, this measurement. Let's hope it works. Yes, it works somehow. So that's this one is an interesting case. Basically, the figure here in the middle, it tells you the GPS location. So it tells you where the measurement was taken. You can see how many stations, how many base stations the signal got received with. Pretty many base stations. You can see how many repetitions, RSSI information, whether the coverage it's better or worse than it was predicted. So you can see that the coverage is better than predicted. You can see the accelerometry values. That's pretty important. That in order you don't want if you are not in the car but you do a stationary measurement, so you can see that the device was not moving during the measurement. You have the voltage and the temperature. And then you have the location, which is given here by Atlas itself. So you can see, and that's the blue circle and the blue spot. You can see the location by GPS. You can see the speed, altitude, and Atlas accuracy. In this case, the Atlas accuracy is really off. It's really off by 12 kilometers, which is quite high. Normally, we see Atlas QH only by around 1 kilometer, but this is high on the hill. Even it's only 100 meters, but it's still it's kind of specific place. So Atlas is not very precise here, and we'll be definitely adding the Atlas Wi-Fi here and the Google location here as well. So you will be able to see the delta between the GPS Atlas and Atlas Wi-Fi and Google directly here. Then we are also listing here the predicted and measured coverage. Basically, because we are saying that the coverage was at minus 20 dB. 20 dB is the margin, is the attenuation. So we are already counting into the predicted model. We are already counting this kind of indoor coverage. And then you have the measured coverage, and you can see that the deltas, the real coverage is a little bit better than the predicted one. And then if you are a Sigfox operator, you can see directly the location of the base stations, and you can see also the distance from the. You can see the distance from the measuring spot. So you can see that 2 base stations that are 50 kilometers from the spot got the signal, and it's pretty far away. It's in the mountains. And you can of course export all the data into either CSV or XLS for your processing. And then I have the second picture. Basically, it's a picture that it's measurement while driving from Dresden to Prague on the highway. So you can see that really Sigfox works even on highway, and this is kind of interesting. We were working hard on the practicality of the colors. Basically, you have each of the spot that's GPS measured has 2 colors. The first one is the Sigfox strength. So basically, whether there was any coverage by Sigfox or there was no coverage. If the coverage was really good, so you have dark green color. If it was weak, it's yellow, and if there is no coverage, it's white, completely white. So that's the upper part, and the part of the pin which is under it is the difference between measured and predicted coverage. So basically, if I would go here, I can see that if I put this place in the middle, so you can see the yellowish color, which indicates that the signal was not so good. We still receive it, but it was on the edge of the measurement. And then you have the light or pink color, which tells you that there should be coverage at this spot and that there was some kind of issue. The same one if you go a little bit left here, so you can see the white color means there was no Sigfox reception at this place. We didn't receive any signal. and therefore and we should receive it. Therefore, the predicted is a dark red, which is like a warning. You should have coverage, and you don't have the coverage here. So basically, while driving, you can see pretty well whether there are any issues, any of the base station local interference, and you can see where you should place more where you should do more control. So you can see two places where we have the red colors in the down section, and there are some red colors here as well. So you can analyze the situation. Basically, it's the ideal case. If it's the downwards, it's when it's blue. So the coverage is better than predicted. So basically we have light blue, which is better than predicted in most of the cases. If it's white, so it's precisely as predicted. So you can see some whites here, which tells you that it's precisely as predicted. Okay, I think that I'll switch to the main interface if I'll succeed. I'm sorry for that. So I stopped sharing of the screen, and now I'm in the main interface. And in the presentation, so I tried to show you some of the data visualization that we are providing, a little bit of the data comparison. We are already with the Wi-Fi, we are already collecting the data, but the visualization for the Wi-Fi, it's not there the same way, as we are still thinking how to do it financially, because Atlas, Google Fonts and Google Location is not free of charge, but we'll see on the usage pattern how much usage will be required. So we are still working on the visualization for the Wi-Fi for the Wi-Fi Atlas. I think that I'm a little bit past my time. I promised 30 minutes. We are currently at 52 minutes. Thanks really for your patience. I appreciate that you stayed with me for such a long time, for 50 minutes, and I am open to any questions or suggestions or suggestions for improvement. It's not an easy device, it's not a gadget, so we try to do it as simple as possible, but in order to work properly, you need to really configure the SIM card, you need to configure the backend. So definitely for the first time usage, someone a little bit knowledgeable should be responsible for the first setup, but then it should be. Yeah, the antennas on the top is just for Sigfox, GSM, and GPS antenna are on this side. So if you have really weak GPS signal, and so you should it should be either the side up or the side up. If you reverse it, the GPS would be under the PCB. It could still work, but the sensitivity would be lower. And Wi-Fi, it's so for GPS, it's a ceramic antenna. I think the same for GSM, and for the Wi-Fi, we have PCB antenna only. Oh, thanks, Phil, for the praise. Having the device since a week and really enjoy using it so far. It's really used in the field. So Sigfox trans planners and the coverage people are really using this device. So and we are using it daily. So it's not something that wouldn't be usable. What is your view of the accuracy of Sigfox prediction versus what you see practically? Good questions. Basically, it depends on the proper setup of the backend. In the past, like when we started the Sigfox operations here, the predictions used to be pretty accurate, or still they are. If it's set up properly. We have seen a little bit growing up of the noise in the field. So the base station setup needs to be set up properly in order to count for the noise. And if the base station setup is done properly, so the predictions are pretty accurate. I know that there were some complaints from some of the operators in the past that the predictions are not completely precise. But what we have seen in the field, they are pretty reliable if the base stations themselves are set up. If the base stations themselves are set up properly. So the only issue is with the averaging, because really the API gives you an average of a few hundred meters. So if you are measuring it really on the top of the hill or just under the hill, where the conditions can fluctuate and can change, it can be an issue. But for most of the city measurement or for most of the countryside measurement, we didn't see any major issues with the coverage prediction. We find that the indoor predictions cannot be relied upon due to structural differences. Yes, of course. If you have a lot of iron rods inside an office building plus the metallic window, the major issue with office buildings is either metallic windows, or quite often also the facades are plated with some metallic plates. So and we need to understand that, for instance, most of the office buildings have their indoor GSM antennas. So if you have a huge GSM buildings, all the operators, they use indoor GSM antennas, and they are not relying on the official open one. So if you have an office building that's metallic inside and outside, you have to use a micro base station. But we have done some testing and micro base station basically when installed properly in the middle of the building. It covers very easily the whole building, and you can do micro coverage even in metallic buildings. And again, the predictions are not. That's important to understand. The predictions are the model is based on the outdoor covered. So outdoor at 1 meter high. So if you go outside of the office building, you measure it outside of the office building at the proper height. So the prediction should be pretty accurate. What Sigfox cannot do, and it's not able to do, is to calculate the attenuation. Is to calculate the difference between the reference point, between the outside and inside. That's pretty important to understand. That the issue is not with the coverage prediction, but the issue is with the attenuation. Therefore, we also recommend covering all the city centers far above the recommended 20 dB margins. We are covering in our territories. We are covering city centers, especially the big city centers. With the office buildings, we are covering them at 30 to 40 dB margins. Okay. Is it possible in the GPS position manually in places where GPS is not available, or site description? A good remark. Currently, we don't have this ability. we think that having the Wi-Fi inside will help us to get the precise Wi-Fi position where there's no GPS position. So that's something that could solve it a little bit. We were thinking of having the remarks, and at least it's not that easy to do remarks because we don't have alphanumeric keyboard on the device, so it's not easy to put remarks directly on the device itself. But we were definitely thinking of having remarks in the user interface for each of the measurements, and we have it in the roadmap, but I'm not able to promise you now. I'm not able to promise you promise the release, but I'll push for it far more. And it's a good remark. Thanks, Jiří. Any more questions or suggestions maybe for the next webinar? I think that we have also concluding the small series of the webinars that we have done in the past 6 weeks. Please have a look at some of our other webinars if they would be of interest for you. We also appreciate if you promote the webinars in your social networks or among your colleagues. All the recordings and presentations are available free of charge online. So please use them to your usage, and please don't forget about the methodology, both about the sales methodology and about the field measurement Sigfox coverage field methodology. So thanks for your attention, and have a beautiful morning for Americas, beautiful afternoon for Europe, and really nice evening and good night for Asia. Goodbye. Thank you.